what I want to talk about here in 7.2 is regular polygons. There's a couple things to discuss that extends the information that we talked about with polygons in general. The first is just to review what a regular polygon is. What special conditions have to be true for a polygon to be considered regular? Regular means all sides are equal, all angles are equal. Okay, so we've already discussed in detail a couple of regular polygons. We discussed a regular triangle. Okay, all sides are equal, all angles are equal. Okay, we discussed, this is called an equilateral triangle. What about a regular quadrilateral? What's that called? Square. So all sides equal, all angles equal. Okay, after you get beyond these two, there's no specific names for them. They're just referred to as regular, whatever classification they are. So if we had all equal sides, all equal angles, we're looking at a regular 5-sided pentagon. If we had 6, again, all sides equal, all angles equal, it would just be referred to as a regular hexagon. And this extends all the way up to whatever n number of sides you might be using. Okay. A couple things regarding regular polygons to be aware of. One, if you're sketching these, easiest thing to do would be to plot points to represent the vertices and then just connect them. So if I wanted you to sketch a regular decagon, okay, how many sides are you going to need? 10. So easiest thing to do, instead of just trying to draw your sides, if you just plot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points, relatively equally spaced, and then just connect those with straight lines, you can usually mimic whatever it is that you are looking to solve. Okay. Now, as you see here, as we go from 3 sides all the way to 10, what shape is a regular polygon getting closer and closer to for me? They get closer and closer to circles, right? Okay. And so we're going to refer to some things. Each of these regular polygons actually has a center. Okay. The center is the center of a circle that would circumscribe that figure. Okay. And then there's one other thing to keep in mind, and that is any regular polygon can be formed with n, where n represents the number of sides, congruent isosceles triangles. Okay, what that means is if you draw or connect each of the vertices of any regular polygon to that center point, you're going to create n number of congruent isosceles triangles. Again, because these segments that you formed are radii of a circle that contains the figure, they're all going to be the same length. So each of these lengths will be the same, okay, and so on. You can draw in these reference triangles. They're all isosceles triangles. Now this is going to come in handy because when we start talking about areas of these, the triangles are going to be useful. Okay. And so the last thing is just to introduce you to some abbreviations or symbols. N represents number of sides. Okay. S represents the length of each side. Okay. Especially in terms of a regular polygon. We've used that for squares already, for the S is the length of the side. And then finally this letter A stands for what's called an apothem. An apothem is basically the altitude of those reference isosceles triangles. Okay. And I use the term altitude because it starts with the same letter as apothem. Okay. But really this A value is just your reference triangle's height or altitude. So here's your apothem. In the square and in the triangle, they exist, but you will rarely use them because for each of these, we've already used other methods for finding these measures. You don't have to use the methods for a regular polygon. Right. And so when we get to areas in the next section that we cover here, the last section of Chapter 7, I'll talk more about all of this. I just wanted to introduce these today.